Hello everyone, this is the fifth video of chapter 8 using the distributive property. On this video, you will use the distributive property to factor polynomials, and later you will solve quadratic equations of the form ax squared plus bx equals 0 using zero product property. So far, we've been using distributive property to multiply a polynomial by a monomial. It can be also used to express a polynomial in factor form. If this is the first time you're learning about the factor form, here's a table show what it looks like when you are distributing or when you are factoring. So the distributing is the same as multiplying. When you are given with an expression, you were told to simplify this. So you were multiplying 3 times a and 3 times b, and you will get 3a plus 3b. And when you have 6y times 2x plus 1, you will multiply 6y to each terms, and you will get 12xy plus 6y. When you are factoring, on the other hand, now you're going to have a simplified form that you're going to put it back to what it was before you were distributing. In this case, you're going to find the greatest common factor. We called it GCF of each terms. And in this case, 3a and 3b both have 3 as a common factor. So if I take out the 3 from each terms, I could rewrite this as 3 times a plus b. This will result in the same expressions if I distribute. Now, when you're looking at the example 12xy plus 6y, first, they both have the term y. When I'm looking at the number, 12 and 6 have a greatest common factor of 6. So I'm going to take out the 6y from both terms, and it will result looking like 6y times 2x will give you 12xy. 6y times 1 will give you 6y. Since they both have the 6y in common, I'm going to take that out and saying 6y times 2x plus 1 will result 12xy plus 6y. If you're not 100% sure, then you can distribute these two terms to see if you can get the same expressions. First example, use the distributive property. Use the distributive property to factor 15x plus 25x squared. Let's do step by step. The first one is 15 and 25. I need to find what is the greatest common factor of 15 and 25. In this case, their GCF is equal to 5. And I need to also compare x with x squared. When you have 1x compared with 2 x's, the greatest number, the biggest number that I can pull out is just 1x. So in this case, I'm going to take out 5x from each term. 5x times what would give you 15x? The answer is 3 and plus 5x times, I'm going to have 5x, one more time, then I will get 25x squared. So in this case, as you see, I have 5x in common. So if I take that out, 5x, in parentheses of 3 plus 5x will result the same as when you multiply 15x plus 25x squared. And that's how I know this is the factor form of 15x plus 25x squared. Part B, now we're going to factor a trinomial. When you are dealing with a trinomial, you have to find the greatest common factor from all three terms. In this case, the first number that I see is 12, 24, and negative 30. Don't worry about the negative yet, but 12, 24, 30 will have the greatest common factor of 6. Now, when I'm looking at the xy squared, x squared y to the 4th power, in this case, the greatest common factor of 3 terms are going to be xy. Then if I pull out this 6xy from each term, now I'm going to figure out what do I need to multiply to 6xy to get the terms back. So for example, 6xy times plus 6 times 4 will give you 24, and I already have xy, but on your format you had xy squared. So I need to multiply one more y in here to get xy squared. The next term I will deal with the negative now. So 6 times 5 will get 30, and then I will have one more x on here, so I can get x times x will be x squared. And when you have just y times what would give you y to the 4th power? The answer is y to the 3rd power. And once you know that there is no common factor of all three terms, you can conclude this is my answer. Here's a part C. So one more time, when I'm finding the greatest common factor of each forms, start with the number. I have 3, 15, and 27. Their greatest common factor is 3. When I'm looking at the variables, ab squared, a squared b squared, ab cubed, will all have a at least once, and it looks like I could conclude b squared because that's the smallest number. So if I take 3ab squared, 3ab squared times what would give you 3ab squared? The answer is 1. Then let's look at the numbers. 3 times what would give you 15? The answer is 5. A times a will give you a squared. B squared times 1 will give you b squared. So I will just have 5a. Plus the last one, 3 times 9 will be equal to 27. A stays the same, but I need b cubed where I'm just multiplying b squared. So I need to have one more b, and that's how I conclude that this is going to be my final answer. This is the part where many students get confused when you're factoring by grouping. There are certain cases you have to do the grouping if you have certain conditions. For example, if there are 4 or more terms, then you will be factoring by grouping. Also, if they have common factors that can be grouped together, or if they have 2 common factors that are identical, or additive inverse of each other. So it might be easier if you're looking at the example to understand. When you have 6ax plus 3ay plus 2bx plus by, you are having 4 terms that I could group them. So first, I'm going to separate the polynomial by grouping a binomials. So here's the first one. 6ax plus 3ay is in one group, and 2bx plus by is in the other group. So now you're only going to focus on one at a time. So in this group, that 6 and 3 have greatest common factor of 3 to begin with, and they both have a at least. On the other side, you'll notice that they don't have any number as a greatest common factor, but they have b. So what we're going to do is we're going to take out this 3a. If you take out 3a from this group, 3a times 2x will give you 6ax. 3a times y will give you 3ay. Plus for the second term, remember that we pulled out the b. So if I pull out the b, b times 2x will give you the terms back, and b times y will get you by. Now, do you notice that you still have one more step to do because you have the same groups right here? This is the part that many people get confused. So when you are grouping them one more time, they have identical common factor. I can take out this 2x plus y to the front, and if I write it 2x plus y up in the front, I'm going to do the same steps. I need to know what should I multiply to this term so that I can get 3a times 2x plus y. Since 3a times 2x plus y was multiplied by 2x plus y times 3, so what I'm doing is I'm just going backward, plus, and the second one was 2x plus y times b will get you the term. This will be my final answer after I group all the terms. If you want to double check, you can also use a FOIL method. And at the end, my simplest form will be exact same as what you began with. Example number 2, part A. So one more time, if I want to factor this, you notice that I have 4 terms. Let's group them into binomials. So I will have 2xy plus 7x in one group. And then you will have negative 2y minus 7. So let's say what they have in common. On this first group, it looks like they both have just x in common. So if I take out the x from each terms, I will have 2y on the front, and then I just need to multiply by 7 as well, so that I can get back this expression. Plus, if I have this negative 2y minus 7, they don't really have a factor other than just negative. So if I take out the negative 1 in the front, negative 1 times what would it give you negative 2y? The answer is 2y, and then I will have negative 1 times positive 7 will give you negative 7. Do you notice that I have the same group right here, 2y plus 7 and 2y plus 7. So if I take that out, 2y plus 7 to the front, I'm just going to figure out what should I multiply to get the form back. So I'm working backward as I'm going forward, if that makes any sense. 2y plus 7 times x will give you the number back, and the next one will be negative 1. And that's how I know this is the factored form of the first expression that you began with. Another example, one more time, we are going to separate the group. So 4xy plus 3y is in one group. And then on the next one, I will have negative 20x plus negative 15. Now you're going to find the greatest common factor from each groups. It looks like both of terms have y in common. So I will have 4x times y will get you 4xy. The next one will be just the 3 will get you 3y back. Now for the next one, negative 20x minus 15. They both have first negative in common, and it looks like they're multiple of 5. So negative 5 could be pulled out. If I think back, negative 5 times what would give you negative 20x? The answer is 4x up here, and negative 5 times 3 will get you negative 15. Once you have the identical group, you're going to factor them. You're going to pull it out to the front one more time, because now that becomes your greatest common factor of each terms. So in here, if I pull that out, I have 4x plus 3, both in common. So if I pull these numbers out, 4x plus 3 times what would give me this expression back? The answer is just a y. So 4x plus 3 times y will be same as y times 4x plus 3. And then if you remember, you had plus minus 5, which is simply negative 5. Now this is the factored form of your expression of part B. Once you practice with more examples, it will get easier. But until then, I know that this could be very confusing. So please review the videos a couple times if needed. If you want more example, please leave a comment and I will make another video. Here's an example 3. The third case, when you are factoring by grouping, there was the additive inverse case. In here, factoring 15a minus 3ab plus 4b minus 20. The first step will be, again, you are going to group them by separating the two terms. So first, I will have 15a minus 3ab in one group plus 4b minus 20 in another group. The second step is still same. You're going to find the greatest common factor from each group. So in here, 15 and negative 3, they are both multiple of 3. And I realized that they also have the variable in common. They both have a. So if I take out 3a to the front, 3a times 5 will give you 15a. 3a times negative b will get you negative 3ab. For b minus 20, they are both multiple of 4. So I can take out the 4 to the front, and 4 times b will give you 4b. 4 times negative 5 will get you negative 20. When you're looking at these groups, unlike the last problem, they are not identical. In fact, they are additive inverse. In order for me to factor one more, what I'm going to do is I'm going to take out a negative, because the fact that negative times negative will become positive. If I take out negative 3a instead of just positive 3a, now you have to repeat the step one more time. So negative 3a times what would give you 15a? The answer is negative 3 times negative 5 will get you 15, and a stays the same. For the next one, if you didn't do this part, but in fact if you took out the negative 3a times just positive b will get you negative 3ab. Now for the next term, I want it to be identical. So if you just keep the 4 up here, only thing is this b and negative 5 needs to be switching the order. For example, what I'm going to do is not just change the number, but if you had 1 minus 3, I could also write negative 3 plus 1 to get the same result. In here, I'm going to pull out negative 5, and then I put b at the end, so that way my numbers are going to be identical without me changing any problem. So the last step, when you have negative 5b with this negative 5b, I'm going to pull it out. And by the way, the third step was when you were using the additive inverse. If I take the groups out, then I will get negative 5 plus b up to the front times negative 5 plus b times negative 3a will get you negative 3a times negative 5 plus b, and then plus the 4. So if you haven't found the pattern yet, when I pull out those groups, what you're doing is you're just copying down what's remaining on the side of those groups. And that is the factor form of your part A. For part B, one more time, if you practice, negative 2xy minus 10x plus 3y plus 15. First, we're going to group them by separating it. Negative 2xy minus 10x in one group plus 3y plus 15. Both terms have negative 2x as a common factor. So if I take negative 2x times y will give you negative 2xy. And this time you will just need 5 to get negative 10x. Plus, if I take 3 out, then I will have y plus 5. For this case, it looks like they are already in group. So I could just take out the y plus 5 to the front. And then on the parentheses for the next one, I'm just going to copy down what's remaining. So on here, I have negative 2x plus I have 3. And that is the factored form of the part B. The zero product property along with factoring can be used to solve certain equations. This property is one of my favorite in algebra. In short term, I also call it ZPP. For any real numbers a and b, if ab is equal to 0, then either a equal to 0, b equal to 0, or both a and b are equal to 0. So think about any number. Any number multiplied by 0 will be equal to 0 no matter what that number you were thinking of. Using that, if you have any polynomial in multiplication, whatever these are, if your answer became 0, I know that either the first term in here has to equal to 0 or the second term has to equal to 0. Or maybe all of them are equal to 0. First example, to solve an equation, solve x minus 2 times 4x minus 1 equal to 0, check the solution. So in this case, since you have two polynomials multiplied and equal to 0, you will be able to use the zero product property, the ZPP. What they're saying is, as a result, if you got the 0 of the product, you would know that either the first term in here has to equal to 0 or the second term has to equal to 0. 0, 0, 0, 0, 0, 0, 0, 0, 0. In order to have x minus 2 equal to 0, you'll be using inverse operation. So in this case, if you add 2 on both sides, you will get x equals 2. On this part, if you have 4x minus 1 is equal to 0, similarly, you're going to add 1 on both sides first. So 4x is equal to 1. And then now, in order to get rid of the 4, you will be using division. Divide by 4 on both sides, x equals 1/4. So what they're saying in here is your x has to equal to either 2 or 1/4 to make 0 at the end. For part B, solve 4y equals 12y squared, check the solution. In this case, if I want to use a ZPP, the first step is that you have to have 0 at the end, just like what you saw on the first problem. So first, let me either get rid of 4y to the other side, or you can do 12y squared to this side. I'm going to get rid of 12y squared from both sides by subtracting 12y squared. That will result 4y minus 12y squared is equal to 0. The zero product property needs to have product, so I need to make this in product form. Another word, you have to make it in factored form. So going back to the steps that we've been factoring, I noticed that they both have 4y as a common factor. So 4y times 1 will get you 4y. 4y times negative 3y will get you 12y squared, and that will equal to 0. Now this is a perfect condition to make a ZPP. So we're going to say if I had this one equal to 0, 4y is equal to 0, then my product could be resulting 0 at the end, which makes y equals 0. Or the second case, when you have 1 minus 3y, that has to equal to 0. So 1 minus 3y equals 0. If I subtract 1 from both sides, negative 3y is equal to negative 1. Y is equal to, if you divide by negative 3 on both sides, this will be positive 1/3. In this case, so if y was equal to 0 or 1/3, I would be able to get 0 eventually, because if you plug in 0 in here, the whole term right here, 4 times 0 will become 0. So whatever this term becomes, 0 times this term has to equal to 0. Similarly, if you put 1/3 in here, negative 3 times 1/3 will become negative 1. So 1 minus 1 becomes 0. So whatever this term in here will be, then if you multiply this one with a 0, you will still get the 0. Part C, solve 5x minus 40x squared is equal to 0, then check the solution. Since you already have the 0, all I have to do is make sure that this is in factor form. So if I want to use ZPP, the first step is make sure that you have equal to 0 at the end. 2, you need to have factor form. In this case, 5x minus 40x squared both have 5x as a common factor. If I take that out, 5x times 1 will get you 5x. 5x times negative 8x will get you negative 40x squared. That's equal to 0. So now you have to make 5x equal to 0, or you will have this term 1 minus 8x is equal to 0. Let's begin to solve this. So 5x is equal to 0, which means 5 times 0 will make you 0. The next one, 1 minus 8x is equal to 0. So subtract 1 from both sides, negative 8x becomes negative 1. Divide by negative 8 from both sides, x becomes positive 1/8. So if you had x is equal to 0 or 1/8, it will result 0 at the end. So my answer will be x is equal to 0 or 1/8 to make this equation true. The last example in here will be using a football. A football is kicked into the air. The height of a football can be modeled by the equation h is equal to negative 16x squared plus 48x, where h is the height reached by the ball after x seconds. Find the value of x when h is equal to 0. So what they're saying is if h was equal to 0, 0 is equal to negative 16x squared plus 48x, I want to know what could be the x values to make h equal to 0. In this case, one more time, we're going to use ZPP. This one already has 0 at the end, so that's fine. However, again, we need the product part by factoring this. I notice that they both have 16x in common. So if I take a 16x, I will get negative x plus 3 will get you the form back. So then I need to know when would this be 0 or when would this term be 0. 16x is equal to 0 or negative x plus 3 is equal to 0. If I solve this one, x is equal to 0 or negative x is equal to, if I subtract 3, I got negative 3 on this side and x becomes positive 3. So that's how I know in here the answer will be either x is equal to 0 or 3. So if I plug 0 into your equation, this is what happens. If I had a 0 on here, this will make 0 plus 0. So yes, that does make 0 and that is checked. If I had a 3 instead, this will make 3 squared will be 9. 9 times negative 16 becomes negative 144 plus 48 times 3 will be also 144 and thus I will get 0 and that's how I can check. This is the end of the lesson. Thanks for learning with me. If you have any questions, please don't hesitate to leave a comment.